Hello everyone! My name is Professor Mega. Here's a pretty puzzling joke. Why did the electrons cross the road? Haha, that's because they want to fill the capacitor's tummy. Huh? What's a capacitor? Why does it have a tummy? So, if you want to discover the meaning of the joke, what are you waiting for? Let's start our adventure right now on How Electricity Works, Part 2. Well, I promise this will never be boring. What exactly is a circuit component? Every circuit component has different superpowers, just like a superhero. Wow, are they going to blast electricity? Whoa, slow down. A circuit component, or electronic component, plays a part in electrical circuits. Some of them can control the flow of the electrons. They are then connected with wires or blocks in order to let them work. But how? Let's get to know some examples of electronic circuit components. There are many types of electronic components, such as resistors, capacitors, and diodes. What is a resistor? A resistor is an electrical component that reduces current flow, or simply, they limit the flow of the electrons. What? I don't understand. It's okay. Let me give you a perfect example. Imagine a river with water that's flowing really fast. What happens if you put rocks in the middle? Now let's compare the two images. With rocks in the middle, the amount of water passing through would be lesser. That goes the same with resistors. You can imagine the electrons or flowing electricity is the water in the river. The rocks are like resistors, slowing down the fast-flowing water. But why do we need resistors? Resistors are extremely important. They protect components by restricting the flow of current. If you have a high-voltage battery connected to a light bulb and then add a resistor, the light bulb starts glowing. But if you take away the resistor, the light bulb generates too much heat because there is too much current flowing through. Then, pop! The filament burns out. What is a capacitor? A capacitor is one of the most commonly seen circuit components. A capacitor acts like a temporary battery. Imagine a circuit that contains a light bulb and a capacitor. The wires are connected together so the current can flow through. This is a closed circuit. When you turn on the switch of the circuit, the electrons flow into both the light bulb and the capacitor. Then, you interrupt the power supply or turn off the switch. The wires are not connected, and this is an open circuit. But the light bulb keeps on glowing for a few seconds. Wow, how did that happen? That's because the leftover electrons stored in the capacitor is released and flow to the light bulb after the power interruption, causing the light bulb to glow. A diode is another common type of circuit component. Just like a one-way traffic sign you commonly see on the streets, a diode only lets the electrons flow in one direction and blocks them from flowing to the other. A diode is a black rectangle with a white stripe in the corner. But some diodes, like this one in snap circuits, have arrows to show which way the electrons must flow, and also contains a LED light bulb on it. Wait a minute, I have a question about electricity. What's the measurement of electricity? If sound is to hertz, then what is to electricity? Aha! Great question. Electricity have different kinds of measurements. The unit of electrical potential, or the energy that is needed to move a charge against an electric field, is called volts. Haha, too hard to understand, isn't it? Let me explain. Volts can be used with batteries. For example, a high voltage battery means that the battery stores high electricity. It represents the amount of electricity stored in the battery. So, I'll show you an example. Imagine two water tanks standing in front of you with a pipe attached to their bottoms. One tank has water filled to the brim, while the other tank only has water filled to the half. Now turn on the tap and observe. Notice that the tank with more water has more current flowing out of the pipe, and while the tank with less water has less current flowing out of the pipe. That goes the same with electricity. The battery with less voltage makes the light bulb glow dimmer, while the battery with more voltage makes the light bulb glow brighter. Another example of electrical measurement is amps. Amps is used to measure the speed of electron flow in a conductor. It's just like measuring the speed of runners on the racetrack. Finally, ohms is used to measure resistance. It can tell how much resistance a resistor has. It is represented with the symbol omega. On some resistors, you can see a label telling how much omega the resistor contains, like this one from Snap Circuits. Now here's a big question. How do people tell how much omega is in a resistor? People use the color of the bands to tell how much omega is in the resistor. Different colors represent a different value. We can use a chart to mark down the value of each color. This is called resistor color coding. Now you know the different units of electricity, but do you know how we measure electricity? We measure electricity with electrical measuring devices. Measuring devices, what are they? Measuring devices are used to measure electricity. There are different types of measuring devices to measure different units of electricity. There is the ammeter, voltmeter, ohmmeter, multimeter, and so on. How do we use electrical measuring devices? Notice on the very bottom or top of each device, there are some holes. We attach two wires to those holes and try connecting them to a certain battery by touching the red wire to the positive side and the black wire to the negative. Then, on the green screen of the device, it shows the value of the battery. Back to my science lab. Today, you have learned about 3 common types of circuit components, 3 common units of electricity, and about electrical measuring devices. Oh, look out the window. It's almost sunset now. I have to go home. Now I gotta get on my electron car. See ya! Oh no, not a one-way diode. Now I cannot go that direction. What should I do? subscribe to our channel, Light Up Kids Science. Light Up Kids Physics.